Hey everyone, today we'll be going over LeetCode problem 121, best time to buy and sell stock. This is another problem of the Blind 75 list, which is a list of problems commonly asked during technical interviews. In this problem, we are given a prices array, and in this prices array, we have several numbers. Each number indicates the price of a stock at a specific day. For example, at day 0, the price of the stock is $7 in this example, while at day 2, in this example, the price of the stock is $5. And what we want to do in this problem is basically return the maximum profit we can achieve from this stock, knowing that we can only do one transaction, meaning we can only buy the stock once and we can only sell the stock once. In this example, our output is 5. And this is because, in this example, the maximum profit can be achieved by buying the stock at day 1 with a price of 1 and selling the stock at day 4 with a price of 6. Therefore, -1 plus 6 is equal to 5, and this is our maximum profit. The brute force of this problem would be to take into consideration every possible combination of numbers that we can have when buying and selling the stock. We would start off by considering every possible combination when buying the stock at day 0. We would see that we can then sell the stock on day 1, day 2, day 3, day 4, or day 5. In each of these cases, we would calculate the profit, and in each case, it would be negative. This is because the price at buying day is greater than the price at selling day for all of these cases. So all of these cases would return a negative profit. We would then go on and consider every possible combination when buying the stock at day 1. Again, we can sell at day 2, day 3, day 4, or day 5. However, we cannot sell at day 0 in this case, and this is because we can only sell the stock after buying the stock. When selling the stock on day 2, when buying on day 1, we get a profit of $4. When selling on day 3, we get a profit of $2. When selling on day 4, we get a profit of $5, and when selling on day 6, we get a profit of $3. The highest profit in this case is achieved on day 4 when buying for $1 and selling for $6, making a profit of 5. Even though this ends up being the solution for our example, we would still have to continue on by considering every possible combination when buying on day 2, buying on day 3, buying on day 4, and buying on day 5. Therefore, for this brute force approach, we have two for loops. One to indicate the day we are buying the stock, and one to indicate the day we are selling the stock. Therefore, our overall time complexity is O of n squared. During each of these iterations of the for loops, we calculate our current profit and see if this current profit beats our max profit, and if it does, we update our max profit. We can optimize this approach using a two-pointer approach, which allows us to achieve a linear time complexity. This can occur because we take into consideration two facts. One, that we want to buy the stock at the lowest day possible, meaning at the day at which its value is lowest. And two, we can only sell the stock after buying the stock. We have here pseudocode, and we see that what we can do is initiate two pointers. One is a left pointer, which starts at day 0, and one is a right pointer, which starts at day 1. The left pointer indicates the day we are buying the stock, while the right pointer indicates the day we are selling the stock. And of course, since we can only sell the stock after buying the stock, the right pointer must be initiated at day 1. We start off our algorithm with a max profit of 0. And we run our while loop until the right pointer reaches the end of the array. Each time we go and compare the price at the L pointer to the price at the R pointer. In our first iteration, the price at R is smaller than the price at left. Therefore, what we want to do, because we are in case 1, is actually move our left pointer to where our right pointer is, because we know that we want to buy at the lowest day possible, and currently the right pointer points at a day at which the stock has a lower price. So for this iteration, we would move our left pointer to where the right pointer is. Then afterwards, we would move our right pointer so that we could start our next iteration. In the second case, instead, R points at a greater price compared to L. So we know that in this case, we can make a profit by selling the stock. We go and calculate our current profit, and we know that it is 5 minus 1, which is equal to 4. This beats our current max profit, so we update it. Afterwards, we simply move our right pointer once again to prepare for the next iteration. In this case, our right pointer still points at a value greater than our left pointer, so we know that we can make a profit. We calculate the profit again. In this case, it's 3 minus 1, which is equal to 2. We do not beat our current max profit, however, so we do not update it. Again, we move our right pointer for our next iteration, and once again, our right pointer points at a value greater than our left pointer, so we know we can make a profit. We calculate again this profit as 6 minus 1, which is equal to 5, and because this beats our current max profit, we update it. Finally, we move our right pointer for one last time, and once again, this points at a value greater than our left pointer. However, when calculating our profit, it does not beat our current max profit, so we do not update the value. At the end, we find that our value is a max profit of 5, and we return 5 as our value. This is a linear time approach because we only run the left and right pointers once through the array. Furthermore, this is a constant space approach because we do not use any extra data structures to save information. We only save numbers, such as current profit and max profit. We'll start off by declaring our left and right pointers and initializing them to positions 0 and 1 in our array. We'll then initialize our max profit to 0 because we know that if we cannot make any profit and all profits are negative, then what we must do is return 0, as per the prompt in the problem. Then we'll start off a while loop, and this while loop will run until our right pointer remains in bounds of the array. Then we have to take into consideration two cases. If the price at right, which is our selling day, is smaller than the prices at left, then what we want to do is move our left pointer to be where the right pointer is. And this is because we know that we have found a day at which we can buy the stock at a lower price. Else, the price at right is greater than the price at left, so we know that we can make a profit by selling at this specific day. So we calculate this profit, and then we check to see if this profit beats our current max profit. Finally, at the end of the loop, no matter what case we're in, we must increment our right pointer. And at the end, when done with the loop, we can return our max profit. Let's make sure this runs. And we see that it works. Thank you very much for watching this video. If you enjoyed it, please like it and subscribe to my channel. I'll see you on the next one.